Good morning. In this session, we evaluate the large-scale manufacture of sodium carbonate and the process exclusively referred to as the Solvay process. The Solvay process, as described, is a large-scale manufacture of sodium carbonate. The main raw materials for this process include brine solution, which is sodium chloride in the conc state, normally obtained from rock salt, ammonia gas, which is obtained by the Haber process with the synthesis of nitrogen and hydrogen, limestone, which is solid calcium carbonate, normally powdery, and in the absence of limestone we have coke, which is exclusively carbon. We also have hydrogen, wine oxide or water, which is used in the slaking process. As you can see in the diagram above, we have what is referred to as the flow diagram for the Solvay process. The main reactions are triggered at the absorption chamber, which is the first chamber amongst the 6 chambers that are required in this process. During the absorption process, ammonia is introduced, followed by brine solution in the presence of water. Now, water as a solvent mixes up brine with ammonia, forming ammoniacal brine. The ammoniacal brine is immediately transferred into the carbonator, which is the third chamber in this process. Within the carbonator, the reaction produces what is known as ammonium chloride and sodium hydrogen carbonate. The mixture of these two substances is transferred to the filter chamber, in which the residue sodium carbonate is obtained and the filtered ammonium chloride is equally obtained. Now, the residue sodium carbonate is the main agent that is roasted at very high temperatures, about 300 degrees Celsius. And when that process occurs, the sodium hydrogen carbonate is reduced to sodium carbonate, which is the product. And in the process, there are remnant byproducts, namely carbon dioxide and water. These byproducts are recycled in the process. Now, reflecting back on what happens at the carbonator, we find that the carbon dioxide that is introduced in the carbonator comes from the kiln or the furnace. The furnace is a heating place at very high temperatures, above 1600 degrees Celsius. Now, at this point, the coke or limestone is introduced, and the high temperatures are required mainly for the purpose of breaking them down or decomposing them to form the required carbon dioxide gas. The carbon dioxide gas, therefore, is the main agent in the carbonator, which oxidizes the ammoniacal brine into ammonium chloride and sodium hydrogen carbonate, respectively. We said that after the carbonation process, the mixture is of a solid sodium hydrogen carbonate and aqueous ammonium chloride, which are separated by filtration at the filter chamber, which, as you can see, is our chamber number 6. And then the residue is sodium hydrogen carbonate, which is used exclusively as the reducing agent for the production of sodium carbonate, the required product in this process. What happens to the remnant ammonium chloride is that it is transferred to the generator, where it meets lime water that comes from quicklime. Remember, from the kiln, we had coke or limestone, which after exclusive heating formed calcium oxide. Now, assuming that we had limestone as a main agent in the kiln, the decomposition of limestone forms calcium oxide. The calcium oxide is transferred to the slaker, or the point where water is added, and when the slaking process meets quicklime, it forms lime water. The lime water is transferred to the generator to meet the filtrate from the filter chamber, namely as the ammonium chloride. The mixture of the two forms ammonia gas, which is again recycled in the process and goes back to the carbonator to represent the second sequence of reactions for the formation of the product sodium carbonate. Therefore, we can say that the kiln or the furnace has the exclusive purpose of generating carbon dioxide from coke or limestone. The slaker has the purpose of dissolving quicklime into lime water by addition of the H2O as displayed there. The filter chamber has the purpose of separating the ammonium chloride from the residue sodium hydrogen carbonate. The generator has the purpose of regenerating ammonia back to the absorption chamber. And the carbonator has the role of mixing ammonium brine with CO2 to form the required sub-agent for the product. The absorption chamber, as we said, is the first chamber from which the reactions begin, where a brine solution meets ammonia gas in the presence of water to form ammonium brine. What then is the role of sodium carbonate? Sodium carbonate is produced here mainly because it has a wide range of application. One, it is used to manufacture water softener. In this case, we refer to it as the washing soda. Two, we can use it to manufacture bleaching agents for paper pulp in the paper industries. And three, we use it to manufacture glass. So you find that sodium carbonate is an agent which has a wide range of applications which are relevant and necessary. And this has been the description of the large-scale manufacture of the substance sodium carbonate by the process exclusively referred to as the Solvay process. Thank you.